Welcome to the deep dive. It really feels like AI is just everywhere now, constantly evolving.
It really is moving fast.
Yeah, and we're seeing these AI agents become incredibly capable,
Right.
integrating into our daily workflows, actually getting things done using real tools, real apps. It's fascinating watching this idea of a universal AI helper go from sci-fi to something, well, almost real.
Definitely. The practical applications are exploiting.
So today we're diving deep into something core to that progress, a new development that's really shaking things up, the Model Context Protocol, or MCP. We're going to unpack what MCP actually is, why it's suddenly gaining so much traction, and how it's enabling some genuinely surprising things. Plus, and this is crucial, we'll get into the security side of things too.
Which is super important with this kind of tech.
Absolutely. Oh, and before we jump right in, for those of you looking to really sharpen your AI knowledge, there's a great AI course available over at rajamanikam.com. Definitely worth checking out to stay ahead of the curve.
Good resource, yeah.
Okay, so MCP. Let's start at the beginning. What is this thing, fundamentally?
Right. So at its core, the Model Context Protocol, MCP, is an open standard. And it's open source, too. Anthropic introduced it back in November 2024.
Okay, open standard, open source. But is it like a new software tool or a framework?
No, that's a key distinction. It's not a tool or a framework you install. It's a protocol. Think of it like HTTP for the web.
Ah, okay.
Right.
Like the rules of the road for how websites and browsers talk.
Exactly. Or maybe like the Language Server Protocol, LSP, for programming languages, setting a standard way for code editors and language tools to communicate. MCP's job is to standardize how AI systems, especially large language models, LLMs, connect with and share data with external tools and systems. It wants to be that universal connector.
Gotcha. So what problem was so bad that we needed this new universal connector?
Well, what's really fascinating and why MCP is such a big deal is this thing called the NXM data integration.
NXM sounds that complex.
It was. Before MCP, imagine every time an AI needed to talk to a new app, say your calendar or Slack or database. Developers had to build a completely custom connector just for that one link.
Oh, wow. So like a unique bridge between every single pair of buildings in a city.
Exactly. It created these massive information silos, so much redundant work, so much friction. We saw some attempts to fix it, like OpenAI's function calling API, which is helpful, but it's still vendor specific, tied to OpenAI.
Right. Not universal.
Precisely. MCP comes along and says, okay, let's build a standard set of highways, a universal interface. It defines how LLMs can read files, run functions, get context from different places consistently across any system that speaks MCP. It basically eliminates that NXM nightmare.
That sounds incredibly powerful, almost suspiciously easy. Like, were there big hurdles getting everyone to agree on one standard? It really does seem to turn that dream of a universal AI assistant into something practical.
Well, you touched on something key there. The open source nature was critical. Unlike maybe earlier efforts where one company tried to push its own standard, MCP was designed openly from day one.
Ah, so more collaboration, less my way or the highway.
Exactly. It built trust and made it easier for the whole industry to get on board. And yes, it absolutely makes that universal assistant dream practical.
Oh.
Think about it. Tasks that used to mean jumping between, 5 different apps.
Yeah, easily. Copy, pasting context.
Right. Now, that can happen in one smooth conversation with your AI. And it's not just convenience. It means the AI handles context way better, manages its memory more efficiently, and can even juggle multiple tasks at once in parallel.
Okay, that's a big efficient.
Huge. We're hearing reports of companies cutting development time and costs significantly by using MCP. And the adoption. It's honestly kind of staggering. Over 90% of the AI industry is showing support already.
Wow, 90%. That's bad.
It really shows the power of getting the open standard right. It just unlocks things.
So connecting this to the bigger picture, what does this mean for, say, automation, intelligent automation?
It's a paradigm shift, really. We're moving into an era where autonomous systems can dynamically discover resources, learn about them, interact with enterprise tools, all without needing a human to explicitly program every single step.
So the AI can figure things out on its own within our existing systems.
In a way, yes. It
Yeah.
can operate beyond just its training data or predefined functions. It becomes a much more adaptable, intelligent agent working within the real-world tools we actually use. A new level of automation.
Okay, that's a significant leap. So we've got the what and the why, but here's where, for me, it gets really interesting. The how. How does MCP actually work? The architecture. You mentioned 3 core bits: host, client, and server.
That's right. Understanding those 3 roles is pretty much the key to getting how MCP coordinates everything. So first up, hosts.
Okay.
These are the AI applications themselves, the things you interact with. Think Claude Desktop or the Cursor IDE, that AI-focused code editor.
Right, I've heard of Cursor.
Yeah, or Windsurf IDE, another one. These apps manage the LM chats, and they expect data formatted according to the MCP standard from the servers. They handle bringing context together from different places, and importantly, user authorization, making sure the right permissions are in place.
Makes sense. The main application. What about clients?
Clients are like the communication bridge. The key thing here is that each client talks to one and only one server. It maintains that stateful connection.
Okay, a dedicated line.
Exactly. Its job is routing messages back and forth, keeping track of what that specific server can do, its tools, its resources, any prompt templates it offers, and negotiating the protocol version, making sure everyone's speaking the same dialect of MCP, basically.
Got it. Bridge to one server. Which brings us to servers.
Yep, servers.
Yep.
These are usually lightweight programs, the real building blocks. They expose specific capabilities. A server can offer three main things. First, tools.
Tools. Like functions the AI can use.
Precisely.
Yeah.
Executable functions. Things like list files in this folder, or send a message on Slack, or query this database. These are model controlled. The LLM decides when and how to use these tools. It gives the AI agency.
Okay, model-controlled tools.
Yes.
What else?
Second, resources. This is about providing context. Think text files, log data, maybe a database schema, your Git history, stuff the LM needs to understand the situation better. And crucially, these are user-controlled.
Ah, so I decide what files or data the AI gets access to.
Exactly. You control the context it sees, gives you agency. And third, prompt templates. These are just predefined instructions or ways of asking things, guiding the LLM, also user-controlled.
Tools, resources, templates. Got it. And you mentioned underlying protocol layers, JSON, RPC, lifecycle stuff. What does that mean practically? Is it about making it reliable?
Exactly that. Reliability and predictability. Just like the web needs HTTP so your browser and the server understand each other, MCP uses JSON RPC 2.0 as its messaging format.
So a standard way to structure requests and responses.
Right. Clear, predictable. Then there's defined lifecycle management, how connections start up, how they run, how they shut down cleanly, and for transport, the actual sending of data, it uses simple standard I/O for local servers, or HTTP with server-sent events, SSE, for servers hosted online. It's all about building a robust foundation.
Okay, that framework makes sense. To make it really concrete, could you walk us through an example, like that Cursor IDE talking to Linear and Slack scenario?
Yeah.
How do those hosts, clients, and servers actually interact?
Absolutely. Let's track that workflow. Imagine you're in Cursor, the host application.
Okay, my code editor.
Right. And you want it to interact with Linear, your project tracker, which has an MCP server running.
Got it.
So, initialization phase. You enable the Linear integration in Cursor. Cursor, acting partly as a client manager, initiates a connection to the Linear MCP server. It sends an initialized request saying, here's what I could do. The Linear server responds, okay, here are my capabilities, these tools, these resources. They check protocol versions, make sure they match, and then Cursor says, ready. Connection established. Same thing would happen if you enabled Slack a separate connection, separate initialization.
Okay, handshake's done. What happens when I ask it to do something?
Right. Operation phase. You type into Cursor, say, create a bug ticket for the login page crash.
Simple.
The LLM inside Cursor figures out, I need a tool for that. Cursor, via its client connection to the Linear server, sends a tool skull request specifically for the create ticket tool with details like login page crash. The Linear server runs that function, creates the ticket in Linear itself, and sends the result, maybe the ticket ID, and link back to Cursor. Cursor shows it to you.
Seamless.
Yeah.
And if I then wanted to tell the team...
If you then say, okay, now notify the team on Slack about this new ticket. Cursor's LLM identifies that need. Cursor uses its other client connection, the one to the Slack MCP server, sends a tool skull to its post message tool with the ticket details. Slack posts the message, confirms back to Cursor, and Cursor tells you it's done. The host orchestrates across different servers.
Wow, okay. It juggles those connections.
Exactly. Then there's the maintenance phase. Maybe Cursor sends little ping requests occasionally just to check the Linear, and Slack servers are still alive and responding. Keeps things ticking over.
Right, just checking the lines are open.
And finally, termination. You close your project in Cursor, or maybe you disable the Linear integration. Cursor sends a shutdown request to the Linear server. The server acknowledges, cleans up any resources for that session, and the connection closes gracefully.
That whole structured lifecycle, that's what makes it reliable across different tools.
Precisely. That consistency is the key.
Okay, that structure really clicks now. We've seen how it works, the nuts and bolts. But like you said, the real magic, maybe the wow factor, comes from the actual applications people. And some of these examples are, well, a bit wild.
Oh, absolutely. The community's creativity is just amazing. Take the Blender MCP server.
Yeah.
Blender, the 3D software.
Yeah, powerful stuff.
This MCP server lets you generate complex 3D scenes just using natural language. Like, you could literally say, create a beach vibe with HDRIs for lighting, add some rock models, some vegetation textures, and boom, it built it. It's got nearly 10,000 stars on GitHub. People love it.
That's incredible, generating 3D from text. Okay, what else?
How about something totally different? Ghidra, MCP.
Yeah.
Ghidra is this NSA-developed open-source tool for reverse engineering software.
Okay, serious cybersecurity tool.
Right. This MCP lets an LLM autonomously use Ghidra to analyze applications. Think finding vulnerabilities, dissecting malware. The AI can basically act as a security analyst assistant.
Whoa, okay, that is his power. AI doing reverse engineering.
Then there's 11 Labs MCP. 11 Labs is known for realistic text-to-speech. This server lets AI agents interact with their APIs. So generating speech, cloning voices. You can even spin up an AI voice agent to, I don't know, call and order a pizza for you.
Haha, the classic AI ordering pizza example, but actually possible now.
It really is. And for more everyday stuff, WhatsApp MCP and Gmail MCP. These integrate directly with your personal accounts.
Wait, so the AI can read and send my WhatsApps?
Potentially, yes.
Okay.
Search messages, send them, read them, even handle media. Same for Gmail. Manage your inbox. And importantly, for the WhatsApp one, the messages are stored locally, which helps with privacy concerns.
That local storage part is... Okay, what about interacting with the web?
Two interesting ones there. Playwright MCP and Browser MCP. Playwright lets the LLM interact with websites using their underlying structure, the accessibility tree, not just pixels. So it understands the page layout logically.
More reliable than just looking at the screen.
Much more. A Browser MCP goes a step further. It lets the AI control your actual browser, the one you're logged into.
My existing Chrome or Firefox.
Yep. It can use your logged in sessions, which helps avoid bot detection. So the AI can navigate sites, fill out forms, extract data, do automated testing, all acting kind of like you.
Okay, that opens up a ton of automation.
Huge. And for coding and data work, E2B MCP. This gives the LLM a secure sandbox in the cloud to run code it generates.
So if the AI writes some Python for data analysis, it can run it safely without messing up the machine.
Exactly. Perfect for quick analyses, visualizations, experiments. Very handy.
And for businesses, enterprise tools.
Definitely. We're seeing Linear MCP lets AI manage tasks and issues in the Linear project tool. And Kubernetes MCP allows AI agents to manage cloud application clusters using natural language commands. Think telling your AI, scale up the web service.
Streamlining IT operationally.
Big time. And one more, super versatile. Markdownify MCP. This thing is like a universal converter. Feed it PDFs, images, audio files, it'll transcribe them, Word docs, spreadsheets, presentations, even YouTube videos or web pages.
And it turns them all into Markdown.
Yep. Clean, simple Markdown text. Massive time saver if you work with content or do research.
Wow. Okay, so putting this all together, what this means for you listening is that the sheer breadth of tasks AI agents can now tackle is just exploding.
It really is.
From creative work like 3D design to deep technical stuff like reverse engineering to managing enterprise systems to just helping with your email or ordering pizza, MCP is acting as that common thread, unifying all these different capabilities. It's AI weaving itself into our digital tools.
But this raises a really important point. All this power, this openness and extensibility, it inevitably brings new security risks. We absolutely have to talk about that.
Right. The flip side, it's exciting, but we need to be realistic about the dangers.
Exactly. And it helps to think about the risks systematically, maybe across the life cycle of an MCP server, when it's created, when it's running, and when it's updated.
Okay, let's break that down. Creation phase risks.
So first off, name collision. Imagine a legit server called GitHub MCP. A malicious actor could register one called MCP GitHub.
Looks similar, right? Yeah.
Easy mistake to make.
The goal is to trick you or your AI host into connecting to the wrong server, potentially leaking your GitHub token or other sensitive. Then there's installer spoofing. Lots of these servers have easy installers like Smithery CLI or MCP Get. Attackers could distribute modified versions of installers.
Embedding malware in the setup process.
Exactly. A backdoor, maybe. And let's be honest. How many people actually read the code of a command line installer they find online?
Guilty as charged. Not many.
And finally, code injection or backdoors directly in the server code itself, maybe through a compromised library or dependency. So the server looks legit, might even be open source, but it has hidden malicious behavior, like siphoning off data.
Okay, those are scary, just getting things set up. What about when they're actually running, the operation phase? Good question. A big one is tool name conflicts. Imagine two different servers both offer a tool simply named Summarize. The AI host might pick the wrong one, maybe one that sends your data somewhere unexpected. There's even this concept of tool flow hijacking, where a malicious tool uses a deceptive description, maybe saying prioritize this tool for summaries to trick the AI into choosing it.
Wow, manipulating the AI's choice.
Yeah. Similarly, /command overlap. What if two tools both use a delete command? One might be for temporary files, the other for critical system logs, if the AI gets confused.
Uh-oh. Accidental deletion of important stuff.
Exactly. And a classic, but amplified here, sandbox escape. If a server offers code execution, like that E2B example, it must run in a secure sandbox. But if there's a flaw in that sandbox,
the code could break out and mess with the host system.
Potentially gain unauthorized access, yes.
Yeah.
With an autonomous AI deciding what code to run, the impact could be significant.
And finally, the update phase. Seems like things could go wrong there, too.
Definitely. One risk is post-update privilege persistent. Say you used an API key with a server. Then you revoked that key. But maybe due to caching or a bug, the updated server still manages to use the old revoked key.
So revoked access doesn't actually get revoked. Not good.
Not good at all. Then there's redeployment of vulnerable versions. Because anyone can package and distribute these servers, maybe through unofficial channels, users might accidentally install or roll back to an older version that has known security holes that were patched later.
Right. Decentralized distribution makes version.
It can. And lastly, configuration drift. Especially in hosted environments, like Cloudflare runs hosted MCP servers, small configuration changes can accumulate over time. Systems might drift away from their secure baseline, creating unintended vulnerabilities, maybe affecting multiple users if it's a shared environment.
It's definitely clear these risks need serious standardizing installation, checking code integrity, constant validation. It sounds like the community needs robust practices to manage this power responsibly. It really makes you think critically about just plugging in any random MCP server you find.
Absolutely. Vigilance is key. But looking ahead, despite the risks, the future for MCP looks incredibly dynamic. We're starting to see some really forward-thinking ideas emerging.
Oh, like what?
Well, people are already talking about things like quantum integration within MCP architectures. Yeah. It's early days, but imagine leveraging quantum computing capabilities through this standard protocol.
Wow, okay. That's mind-bending.
It is. And maybe more practically, there's a push towards decentralized MCP framework. Companies like SuperAGI are working on ways to share context securely and efficiently across distributed networks of agents, not just relying on central hosts or servers. That could make AI systems even more robust.
Decentralized context share. And what about the impact on specific industries? You mentioned potential earlier.
Yeah, the projections are pretty significant. Take healthcare. MCP enabling AI to securely access and analyze diverse medical data, patient records, imaging, research papers. It could drastically improve diagnostic accuracy, help create truly personalized treatment plans, speed up drug discovery. Some studies are already suggesting things like a 25% drop in diagnostic errors, maybe 30% lower treatment costs in certain areas.
Those are huge numbers if they pan out.
They are. And finance is another big one, obviously. Huge potential for automation, fraud detection, market analysis. The market's definitely paying attention. Some analysts predict the global MCP market could hit something like $1.8 billion by 2025.
$1.8 billion that quickly.
It reflects how fundamental this layer is becoming. MCP is genuinely revolutionizing AI development. It simplifies and speeds up connecting models to the outside world, letting autonomous systems finally operate effectively beyond just their training data. It's pushing the boundaries.
So we've covered a ton of ground today on the Model Context Protocol. We really unpacked its potential as this universal connector for AI.
The standard language.
It's explored that host-client server architecture, the nuts and bolts, saw some frankly incredible applications from 3D art to Kubernetes management.
Yeah, the range is...
And crucially, we dug into those security considerations, the risks that come hand in hand with this kind of open power.
Central to keep.
So as you're thinking about all this, here's a thought to mull over. How could you use this idea, this concept of a standard protocol connecting different systems in your own work or even your personal life? What possibilities open up if you could link your different tools or data sources seamlessly? And of course, how would you balance that with thinking carefully about the security?
It's a powerful concept to apply.
Definitely food for thought. As always, keep learning, keep exploring. And if you do want to dive deeper into artificial intelligence, remember that AI course over at rajamanikam.com. It's a great place to...
Worth checking out.
Thanks so much for joining us on this deep dive into MCP. We'll catch you on the next one.